Hey people, so today we're doing solutions preparations. Now, if anything in the grade 11 curriculum, this topic is probably, I would say, the most useful one of them all. I don't mean the others are useless, but this one is really useful in many ways. And you'll see by the end of this lesson, you'll know exactly what I mean by, the usefulness of knowing how to do these things. Okay? And that is solutions preparation, because one day as a chemist or any sort of, scientist working with solutions and stuff like that, you're going to be asked to make a certain concentration of something. And that is bound to happen one day, And to make sure that your boss is happy, is not gonna go, firing you up. You better do what he says. You better give him what he wants, or you'll be in a lot of trouble, man. So knowing how to do these things is obviously a plus, and as a scientist, this is probably one of the more basic things that everybody should know. So let's move on right on to it. Solutions preparation. How do you prepare a solution of exactly what you want? Now, there's 3 types, okay? Starting with the first type, which we are going to call A, is known as dilution. This one is probably the one that you'll do the most, okay? Because most likely when you receive a solution, or when you are asked to prepare a solution, you're preparing it from a stock bottle. Okay? A stock bottle is usually very concentrated. It's almost like buying those frozen juice from the supermarket. You know those frozen juice that you buy that comes in a can? They taste really disgusting if you don't dilute it. You know one of those? I had the opportunity, of course, of drinking one of those without diluting it, just for the sake of a dare. And that didn't go very well the next day. And let's just say that I'm not going to do it again. But dilution is something that, chemists do all the time. Okay? Taking a stock solution that is highly concentrated and adding water to it. Now, the trick here is, how much water are you adding and how much are you really preparing? So let's take a look at a sample question that I'm just gonna blindly make, okay? So let's take a look at example 1 that is based on dilution. So let's say you have a stock bottle right here, okay? And this is, let's say, sodium chloride. It's a salt solution, and it has a concentration, which you just learned not too long ago, molarity. So it has a concentration of, let's say, 2.5 moles per liter. All right, and you have, let's say, 5 liters of this. Okay, and this is the question. You are going to you took, let's say, 500 milliliter of, you took 500 milliliter of your stock solution, and you added 2 liters of water. What is the new concentration of your solution? Now you'll notice I use a square bracket here, okay? Square bracket is sort of like a shorthand notation for the word concentration. So instead of writing concentration 50 million times, because I have 50 million questions for you. I'm just going to write a square bracket, then you'll know. Okay, so what is the new concentration of your solution? So let's go back and look at this question one more time. Okay, so you took 300 milliliters out of this. Oh, let me use this. 500 milliliters of this. Okay, and then you took 2 liters of water and you added to this. What is the new concentration of your solution? All right, this is the dilution formula that you need to use. You know this is a dilution question because you're adding water. Okay, so you're going to have C1V1 equal to C2V2. This is known as the dilution equation, where C1 is your initial concentration, V1 is your initial volume, okay, usually of course in liters, because molarity is moles per liters, unless you decided to go with millimoles per milliliter. C2 is your final concentration, which is what we want to find for this question, and V2 is your final volume. Now, V2 is not how much water you're adding, duh, it's the final volume. Be careful with that, huh? So, let's do this question, okay? Now, before you do anything, you should think to yourself, okay, my original concentration is 2.5 molar. Yeah, that's what you call molarity, okay? People like to call it molar. Sort of like, you know, the flat teeth at the back of your gum, you know, molar, the one that is used to crush things. Whatever. You have 2.5 molar, and you took some of these, okay? You took 500 milliliters of this. It's still 2.5 molar, but you're going to be adding water to that 500 milliliters. That means your concentration is going to drop because you're lowering the concentration. You're diluting the solution, right? So you should expect an answer that is smaller than 2.5. If you don't get something smaller than 2.5, means there is problems. There are problems. Hopefully not with you. All right, let's do this. Let's do the solution here. Let's do the solution. Let's find out the answer. All right, so initial concentration. So initial concentration obviously is 2.5 moles per liter. Okay, that's the initial concentration. And what is the initial volume? Now the initial volume obviously is not 5 liters. That's what's in the stock bottle. And theoretically, I shouldn't even give you that number. Okay. The initial volume is 500 milliliters because that's what you took out of here. That's the initial volume. Okay, not the volume of the stock bottle. You're not adding water to the stock bottle. No. You are adding water of what you took out of the stock bottle, if you know what I mean. 500 milliliters. Now, be careful here. Okay, you don't want to put 500 milliliters as volume 1 because concentration is in moles per liter, which means the volume entity here is liter. So most likely you might want to change this to liter as well. And that's something very easy to do. You guys can easily do that. Okay, that will equal to C2, which is what you want to find, times V2. Now, as I said, be careful here. This is final volume. It's not how much water you added, because a lot of people, for some reason, would think that this is the amount of water added. No. It's the final volume, which is 0.5 liter. Okay, which is the amount in your stock solution, plus the 2 liters of water. That's your final volume. Now, using your marvelous math skills, okay, you guys can probably tell me that your final concentration is going to be 0.5 moles per liter. Okay, hopefully I'm right and I didn't make a mistake of calculating. I don't know. You guys should be okay. All right. Now, I have lots of these questions for you to work on, so it's probably a good idea that you guys try a lot of these things. All right, so this is a good example, obviously, of using the dilution equation, but this question is not very real. Okay, this question is not very real. It's not real at all. This is more of a real question. So check this out. Example 2. Mr. Chung wanted you to prepare I guess an NaCl solution that has a concentration of 0.2 molar and I don't know, 3 liters. Okay, so Mr. Chung wants you to prepare a NaCl solution that has a concentration of 0.2 molarity, and he wants 3 liters of it. Okay, he gave you a 12 molar stock bottle. Wow, what a generous guy. Okay, what are you going to do? What are you going to do? Because you want to make Mr. Chung happy. You work for Mr. Chung, and he wants this concentration, and he wants this amount, and you better give it to him. Oh, he gets mad. You don't want to play games with him. So, as I said, okay, he gave you a 12 molar stock bottle. So what are you going to do? The question is, what are you trying to find? So sometimes what I like to do is I like to draw this. And so here's a stock bottle. Okay, here's a stock bottle. And it's NaCl 12 molar. And somehow you need to make let's draw for it. Usually you make it in a volumetric flask. Okay, you've probably seen these before. Okay, this is called volumetric flask. These are useful in a sense that allows you to prepare solution in a very accurate sense, and you'll probably be asked to use something like this. Okay, and this is going to be 0.2 molar, and this is exactly 3 liters. Pretty cool, huh? So you want to go from 12 molar to 0.2 molar. So obviously you're diluting it to get that, right? So the question is this: how much of the stock are you going to take from here and put it in here and then add water to it? That's what you want to find out. Okay? Because you want to go from 12 to 0.2. Okay? Now, some people might think, oh, well, can I just use all of this and add a whole bunch of water in here until it is 0.2? I mean, keep diluting it with water. Keep diluting it with water. Keep diluting it with water. Huh. How sick would that be? Well, Mr. Chung is gonna be very upset that you wasted his very expensive 12 molar stock bottle by diluting it all to 0.2. He doesn't want... You're going to end up with like 50 liters of 0.2 molar. That is a waste of chemical. Instead, you are to take a certain amount of this. You are supposed to take a certain amount of this, and you're going to put it into your volumetric flask. This certain amount you have to calculate. And then you're going to add enough water in here to make it 3 liters. That's what you're going to do. So when you think of that strategy, which variable are you really looking or you're trying to calculate? Because I have C1V1 equal to C2V2. Okay, this is a dilution question. You know it's a dilution question, because your final concentration is lower than the initial concentration. So definitely what you're looking for is not C1 and C2. You know your final volume. It is 3. That's what you want to target yourself with. So most likely the variable that you want to find is initial volume. You want to know how much of this you're going to take out of the stock. So let's do that. So the initial concentration here is 12 moles per liter. Okay? You want to know how much of this you're going to take out. That will equal to your final concentration, which is 0.2 moles per liter, times the final volume, which is 3 liters. Okay? All right. Let's do some math. Let me bust out my calculator. It's not like I can do this in my head, but obviously I don't want to. So the answer is 0.05 liters. Or you can say 50 milliliters. Okay, better in terms of accuracy when you're actually measuring something like this. You will use a graduated cylinder that is given to you in milliliters. So. This is a good answer, okay? But this is not the answer yet, because you're asked in this question, what are you going to do? You're not going to say 50 milliliters, because that's not what they're asking. They're asking what you want to do. So you want to explain to, the person who's asking you to do this, what are you going to do? Not just say 50 milliliter. That's not going to get you full marks. So what is this 50 milliliters? That's the first thing. 50 milliliters means you're going to take 50 milliliters out of this. So you're going to take 50 milliliters out of your stock and you're going to put it into your flask. Then you're going to add enough water in here to make it 3 liters. So which means to finish off this question, you need to know how much water you're going to add, because your target is 3 liters. Okay, so 50 milliliters. So in this case, let's go back to liters. So 0.05 liters plus something will give you 3 liters. And obviously, this something is going to be 2.95. Okay, so therefore, this question requires a therefore statement, because you're going to explain to Mr. Chung what you're going to do, or you're just going to do it. That you took, or let's just say you didn't do it yet. You are going to take 50 milliliter of NaCl from the stock and add 2.95 liters of water. That is how you would satisfy what Mr. Chung wanted you to do. He wanted you to make a 0.2 molar, 3 liters worth of NaCl. He gave you a 12 molar stock bottle. Okay, you're going to take 50 milliliters out of this and put it in here. And then you're going to add 2.95 liters of water, and you're going to put it in here to make up that 3 liter mark. And you're going to give this to Mr. Chung, and you say, "Sir, I got what you want. Now, give me good grades." And he'll probably give you good grades. He's a very nice guy. Anyway, I hope you guys are okay with that. That's, dilution, as I said. This question is definitely very real, because somebody is going to ask you to do something like this, where they're going to say, "Hey, prepare me this from this." Somebody's going to ask you. Okay? Could be Mr. Chung, or could be myself. Anyway, that's, the first type of solutions preparation. So let's move on and look at the second type. The second type is sort of like the opposite of the first type, okay? Because the first type is asking to dilute things. You're making things less concentrated by adding water. Well, type B, okay, you're making things more concentrated by adding solutes. Sometimes these solutes comes, of course, in solid form. So you're gonna have to make, I guess, one assumption. A very weird assumption, but you're gonna make one anyway. So type B, adding solutes. Okay, by adding solutes, you are raising the concentration because you're gonna keep, I guess, the amount of solvent constant. So let's write that down. Okay, solvent remain constant. Okay, and this solvent is usually water because water is our universal solvent. So let's take a look at this question, example 3. You have an existing solution. Let's call it NaCl again. Where today is an NaCl day. Today's a salty day. So you have 0.5 molar of this, and this is 2 liters. Okay? Now, you're gonna add, I don't know, 3 grams of sodium chloride in there. Okay? Now, did you just make this solution saltier? Definitely. What that means is that you're raising the concentration from 0.5 to more than 0.5, and I want to know what is the concentration of your new solution. Okay, so you know for a fact that you are adding 3 grams of salt into an already existing solution that has a concentration of 0.5. By doing that, you are raising, okay, you are raising the concentration. So your final answer is going to be higher than 0.5. If not, there is a problem. Okay, it's a big one. So let's do this. So let's do example 3. Now, no equation here. There's no dilution equation because this is not a dilution. There's no adding concentration equation because there is no such thing. So what you're going to do is that you're going to use this equation. We've seen this before. This is the equation to find out what concentration is in molarity by dividing moles by volume. Okay? However, this is not just mole. This is total mole, NT. Okay? The total amount of moles. What do you think that means? It's very simple. You want to know how much mole is in here originally. So you have 2 liters of 0.5 molar of NaCl. How much mole is in here? Then you're going to add how much mole is 3 grams. And you're going to divide that by the volume. Now, the assumption that I mentioned here is this. You're going to assume that 2 liters remain 2 liters, even if you added NaCl in here. Now, you may be thinking, if I add solids in here, wouldn't this number goes up because I will see this mark going up by a little? You would, actually. You would. But you're going to assume that it didn't. So you're going to assume that volume remained 2 liters. I know it's a weird assumption, but you're going to make that assumption because whatever that is not, it's really not a big deal anyway. Okay? So as I said, this equation, you're going to put a T here to give it the understanding that you're looking at total mole, which means you want to find out how much mole is in here. you want to find out how many mole is 3 grams, and you're going to add the 2 because that's exactly what you did over the volume. So let's do that. Let's use a different color. So let's take a look at here first. How many mole is in there originally? Well, I know the equation. 0.5 moles per liter times 2 liters will give you mole. Okay, the power of factor label method, huh? Told you it was useful. This will be 1 mole. So what's in here is 1 mole of NaCl. Okay, you know how to do this because you were given lots of questions to do, in previous class. So this right here has 1 mole of NaCl in it. Here, okay, you have 3 grams of NaCl that you're adding into. What's the mole? Well, we know how to do that, okay? 3 grams of NaCl is really just, quickly, let me just do this division. I can't do that in my head. It's really 0.05 mole. Just rounding it to your nearest hundredth, okay? So, your solution has 1 mole of NaCl. You are adding 0.05 mole of NaCl. What you're going to do is that you're going to combine these two, and you're going to put it here. Okay? So, C is equal to 1 mole plus 0.05 mole over, that was a little hiccup, over 2 liters. Okay? Remember what I said. You're going to keep the volume consistent. You're going to pretend, of course, that you didn't change the volume. And theoretically, you really didn't change the volume. All right. Let's do the math. Okay, so this is 1.05 divided by 2. So the answer is 0.525 molar. Now, after doing this, you should ask yourself, does the answer make any sense? Is it 0.525 molar? And of course it is. Okay, you added solutes in here, so it only makes sense that the concentration increase, and it did. It didn't increase much. Well, what do you expect? 3 grams is really not a lot. All right, so that's what you do, when you're adding solids. So again, we looked at a real question. Okay, let's look at another real question. Example 4. Okay. Let's use another teacher. We have Mr. Chung. Mr. Lee. Okay. Mr. Lee wanted 0.75 molar of NaCl. Okay. He gave you a 0.65 molar at 2 liters of NaCl. I don't know. What are you going to do? Okay? So obviously, in this case, you are making things more concentrated, right? So as I said, don't be afraid to draw these things. So Mr. Lee gave you something. So this is called an Alamar flask. Okay? And it is NaCl. It is 0.65 at 2 liters. That's what Mr. Lee gave you. And Mr. Lee says, hey, this is too low in concentration. I need this to be a little bit higher. So you want to turn this, okay, into 0.75. What are you going to do? Well, you are raising the concentration in this case. So you're not diluting. Obviously, you're not going to put water in here, right? If you put water in there, this number is going to get lower. So what are you going to put in there? You're going to put NaCl in here. You're going to put NaCl in there. But how much? Okay, how much NaCl are you going to put in there? Well, and when it comes to how much, you better not give me the answer in moles, because there's no such thing as an analytical balance that weighs mole. They never ever invented that. You know, all your balances measure stuff in grams, so therefore your answer has to be in grams. All right, let's take a look at how to do this. Okay, let's take a look at the strategy in terms of how to do this. It's actually pretty simple. Again, you want to find out how much mole is in here. Okay, you want to find out how much mole is in here. So you're gonna do this. Okay, 0.65 moles per liter times 2 liters. This will give you the amount of mole that exists inside the solution initially. So that's 1.3 moles of NaCl. Hopefully I didn't do this wrong. Okay, now you want your final concentration to be 0.5. What that means is how many moles is in your final concentration. So in your final concentration, you want 0.75 moles per liter. And I'm assuming that, you're just going to be adding NaCl in there and you're not really changing the volume. So the volume remained the same. Okay? The volume remained the same. Unless Mr. Lee wants more, then you do something else, which we will talk about it in type C. So it'll be 1.5 mole. So check this out. Check this out. You pretty much have this question done. Your initial concentration here is worth 1.3 mole of NaCl. That's how many moles of NaCl is in here. Your final concentration has 1.5 mole of NaCl. The difference in mole is how much you added in, right? Right? So initially you have 1.3 moles in there. Your final solution will have 1.5 moles in there. The difference here is what you added. So, to finish off this question, you're going to take 1.5 mole and you're going to subtract that by 1.3 mole. And the answer, of course, is 0.2 mole. You're going to add 0.2 mole of NaCl into this Erlenmeyer flask. But as I said earlier, there's no such thing as a mole balance in this world. Nobody invented one, because you would have to invent a balance for every single compound. That's ridiculous. Who would invent something stupid like that? So what you need to do here is that you need to turn moles back into grams by multiplying it by 58 grams per mole. This will give you your moles into mass. That's your final answer. Okay? That's your final answer. You're gonna measure out 11.6 grams of NaCl, and you're gonna dump it in there. So you will turn the concentration from 0.65 to 0.75, just like what Mr. Lee wanted. Hopefully you're happy with this. Again, this is another very real question. I like real questions. Okay? What's the point of having questions that aren't real and you're never going to be asked to use or do? All right. Again, I hope you're happy with this. Let's take a look at the third scenario. Okay, which I will... And the question will probably blow your mind. Okay? adding all entities. Okay? This question, when you look at it, is going to blow your mind. You're going to think, oh my God, I am going to cry. But no need to cry. It's just look messy, but it's not a big deal. I'm going to draw this question. I want to know, what is the new concentration? If I decided to do this, I am going to add an NaCl solution that is 2 liters at 0.5 molar. I have another one of these right here. It's a little higher in concentration. It's 0.7 molar, but it has a higher volume of maybe like 2.1 liter. Also NaCl. I'm going to add this in here, and I'm going to add this in here, and I want to know what is my new concentration. That's what we meant by adding all entities. So let's take a look at this. Now, this is actually very simple. Okay, if you're adding 2 solutions together, you should ask yourself, what am I going to expect? One of the concentration is 0.5. The other concentration is 0.7. If you were to add these 2 solutions together, you should expect your new concentration to be somewhere between 0.5 and 0.7. Now, it wouldn't be dead on between because volume plays a role too. This is just a little bit more of this than this. So to do this, this is what you need to do. You need to find out what the new concentration is by figure out what the total amount of mole over the total amount of volume. So let's do that. Let's take a look at how much mole is in here. So 0.5 moles per liter times 2 liters. That's 1 mole. So literally, when you're adding this to this, you're really just adding 1 mole of salt in there. And let's take a look at this. This is 0.7 moles per liter times 2.1 liter. So how many mole is this? Well, let me grab my calculator and just accurately calculate that for you. That's 1.47 mole. So 0.7 molarity at 2.1 liters, a little bit more mole than 0.5 at 2 liters. That's obvious. So what you're doing is that you're adding 2 of these in here. So you got your total mole if you think about it, okay? So your total mole is 1 mole plus 1.47 mole. Now you want to know what is the total volume, which is really right in front of you. Okay, it's, you're adding 2 liters and you're adding 2.1 liters. Add them. Just add them. So 2 liters plus 2.1 liters. Okay, so let's calculate this. Okay, so 2 plus 2.1. Your answer is 0.60 mole. I like 2 decimal places. Okay, so here you go. Hey, in this case, it is kind of in between. It is in between. But if you take into the 3rd decimal place into account, which is really 0.602, it's a little bit more skewed towards this end. But overall, it is kind of in the middle because 2.1 and 2 is really very close to each other. All right. So that is what I say, a pretty good question to think about. Okay. Let me give you another one. This will be my last worked example. The next example, which is example 7, will be the very last, and that's going to be yours. And I want you to think about it. You have the whole... Yeah, never mind. All right, so let's draw this again. Then. Why write it in words? I want to know what is the new concentration, okay? New concentration. Let's add a whole bunch of things. I have NaCl. This is 1 liter at 0.5 molar. Let's put that in here. I have another one right here. NaCl, 1.5 liter at 0.7 molar. Let's put that in there. Let's put another one. I know, I'm being so annoying. This is a 2 liter at 0.3 molar. Put that in there. Oh, one more. Let's do one more. Look, watch. I'm gonna add water in here. And that's gonna be 3 liters. Look at that. After adding those, I'm gonna dilute it with 3 liters of water. Now, just because I add water and I had a whole bunch of things, that doesn't change the fact that this is gonna be a lot harder. I hope you don't think about dilution equation, because that would be too much thinking on your part. The idea is the same thing. Exactly the same thing. Okay, exactly the same. You're going to find out exactly how many moles of NaCl you added in here. You added this. Whatever amount of mole is in here. Okay, this. And this. Let's take a look at that first. There is no moles in here. At least no NaCl mole. It's just water. Okay? So don't go around and say, oh, let me find out how much NaCl and moles is in here, because you are going to be quite disappointed. All right, let's take a look at how many moles is in here. Okay, so that's 0.5 moles per liter times 1 liter. I hope you don't need a calculator for this. Okay, so that's 0.5. Let's take a look at how many mole is in here. Okay. Isn't this one I might want to use a calculator? I know. Why would you do that? It's not like it's hard or anything. Well, I'm not good in math, okay? So that's 1.5 mole. So let's take a look at here. Okay, I don't need a calculator for this, that's for sure. That's 0.6 mole. All right. So, hey, you know what? I found my total mole. My total mole is 0.5 mole plus 1.05 mole plus 0.6 mole all over. Now, total volume. I have 1 liter, 1.5 liter, and 2 liter. Let's add those in for now. 1 liter plus 1.5 liter plus 2 liters. Now. Your total volume is not going to be just the combination of those three, because you added water at the end. You don't really have to add this at the end. You can add this whenever you want. So your total volume has to take this into account. And this is the only entity that you need to take into account when it's based on water. So to finish this off, you added 3 liters at the end, which is based on the water volume. So let's calculate this. It's always nice to have a calculator on hand. Okay, when I go to trips, I always have a calculator in my pocket. Now I have a phone, but before the smartphone, I always have a calculator in me. Always doing conversions to see if it's a good deal. I'm one of those. That is your answer. Okay? Which kind of makes sense, right? 0.29 molarity. I don't know. It's so messy here. It's really hard to see if it really makes sense. But that's what it is. All right? Hey, that's solutions preparations for you. Okay? Hopefully you see the usefulness of this, and maybe one day you'll apply it in real life. Thank goodness this is a video that you can play back at any time. I have one more question for you. Okay? One more question. Oh, what did I do here? This is example 7. I'm going to draw this. I want you to figure this one out on your own. So I have an unknown concentration. I'm going to add a whole bunch of things in here that you're going to be so upset. All right. Let's stick with NaCl. This is 0.2 molar at 2 liters. Dump that in there. I have another one. Also NaCl. 3 liters at 0.3 molar. Yeah, dump that in there. I have 4 liters of water. Dump that in there. You know how to do this, but I'm not done. I'm not done. 10 grams of NaCl. Dump that in there. I'm not done. I'm not done. Do you remember this? Do you remember that? I hope you remember that. 15% WV. Because remember, sometimes concentration doesn't always have to be in molarity. Sometimes people still use this percentage. So 15% WV, okay, at 3 liters. Dump that in there too. I hope you remember what WV is. I hope you remember what WV is. Okay? And I'm going to dump one more thing in there. I'm going to dump one more thing in there. And that is 1 liter of NaCl. Actually, you know what? Let's just call it. I think let's not make this too confusing, or else you're gonna get too upset. Right. So, hey, here it is. Okay, I just dumped 5 things in there. Hopefully, it doesn't bother you that much. Anyway, I will take this up the next time we speak. Maybe a long time, but yeah, we'll take this up. All right, guys. See you later. Bye.